Alright guys, so this is the beginning of test 2 for my Cal 4 review session. And first off we're going to do, it's chapter 15, which is what this is from, is mainly about double integrals. And what we're going to do is this first integral as a little bit of practice. And that's all I'm doing in this video. A bunch of practice problems from my old tests. So we have the integral from 0 to natural log of 2 and the integral of 1 to natural log of 5. E to the 2x plus y dy dx. So from doing this equation we can find out it's separable because e to the 2x plus y is just e to the y times e to the 2x. So you can separate them. And then the inner one is dy, so it's the natural log of 1 to natural log of 5, e to the y dyx. So what we get is, once we take the derivative, is e to the ln of 5 minus e to the 1 times e to the 2x, ln of 2 minus e to the 0. And this becomes, so this 2 out in front of the natural log becomes the power of it. So it's really just 4. So it's 4 minus 1 times 5 minus e to the 1. Wait a minute. What did I forget? I see what I forgot. So when you're taking the integral of e to the 2x, it really becomes e to the e over 2. And then this becomes e over this, 2. So it's 3/2 times 5 minus e. And that is our answer. All right. Okay, so this is problem 2 from my test, and we have the integral, double integral of dx and plus y dA. And D is going to be a triangle bounded by x equals 0, y equals 0, and y equals 3 minus x. Now, we all know y equals mx plus b, so this is 0, this is our x, this is our y. And this is our origin, so y equals mx plus b, b is going to be 3, and our thing is going to be decreasing, and that's our triangle. So we're going to take the area of that, and to do that, we're going to do 0 to 1, 0 to 3 minus x. Am I right? Is this test 3 or is this test 2? This is test 2. This test, yeah, okay. So the only thing I did wrong is it's not from 0 to 1, it's from 0 to 3. And that's because our bounds are from 0 to 3. Honestly, that's some conceptual stuff, and I don't really even understand it myself, but it's like you're taking the strips from here to here, right? That's a very thick triangle for a very small, thing. But pretty much what you get is x plus y, and then is it dx dy? No, it's dy dx. This is one that conceptually I don't understand the best, but I can understand how to do it. So, because there's a plus, you can't separate it. That's how I understand it, but apparently there are other things as well. So, then we just take the double integral of it. Yx plus y squared 2. Zero, and then we still have one integral, so you can still write it or you don't have to. I usually don't write it, unless it's like urgent. So we get 3x minus x squared plus x squared minus 6x plus 9. This is over 2 dx integral from 0 to 3. And then we go on to the next bit, which I'm going from this to this, but whatever. So comes okay. Well, it seems that I did it wrong on my test, and she gave me full credit. Or I think I did it well, but when you're taking the integral and it goes to the second, it's divided by 2. And that's what I did right here. But on my test, I didn't do that. I just have y squared. Which doesn't make sense. It really doesn't. But it's not very hard to take the thing of this. It's just 3x squared over 2 minus x to the third over 3 plus x to the third over 6. So that is minus 3x over 2 squared plus 9 over 2x. And eventually we have to plug in 3 and 0. 0 and 3. And that leaves us with 27 over 2 minus 9 plus 2/3 because it's 27 over 6. 2/3? Wait a minute. Plus 3 halves. No, it's not halves. Plus minus 27 over 2, and then plus 27 over 2. And that's minus like 0. So this one cancels, this one cancels, this one. How does it equal 9? Okay, so this becomes 36 over 2. 36 over 2 is 18. So it's 18 minus 9, which equals 9. Okay, I got the right answer this time. How did she legitimately gave me this. My teacher's very nice, apparently. Alright guys, that's question 2. Okay guys, so this is the third problem of the test, and this is reversing the order of integration. So we have the integral from 0 to 1 y to 1. X squared e to the xy dx dy. So x is equal to y, x is equal to 1, y is equal to 1, and y is equal to 0, because if it's dx dy, this outer one is y is equal to, and then, I finally, so for the longest time I've been wondering, or well, not the longest time, but right before studying this, I was like, oh, why does this happen? It's dy and dx, so the inner integral is x is equal to on both, on top and bottom. So x is equal to y, x is equal to 1, and that's where we get that from. And y is equal to 0, y is equal to 1. Oh, big brain. Anyway, from that we get this triangle, and reversing it is all as simple as making 0 to x, because if you're going to reverse it, if you're doing it one way, and then you're going to go the other way, all you're going to do is just flip it. So what I did on my test was, it was from 1 to x, 0 to 1, but I was wrong. It's 0 to x. So make sure to notice that, because what you're doing is you're going to make 0 equal to y for this first one, and then for the second one you're just going to make y, x is equal to 1, but it's going to be y is equal to that x. And then for the second one it's just 0 and 1. But now it's just time to integrate it, and this is the easy part. So x squared y e to the xy 0x, so it equals x to the third e to the x squared, right? Yes. Okay. Where did that 0 come from? Oh, because it's 0. Oh. Wait, but if it's, did she do it wrong? Oh no, she just factored out, oh, we're taking the integral in respect to y, so it's not times y, it's divided by x. Okay, I'm getting my integrals and my derivatives mixed up. When you integrate e, and when you take the derivative, it's times whatever's left. But when you integrate, it's divided by whatever's left. Not y. It's not y. It's not y. It's x. Okay, so that means I did this incorrectly, but not to. I should have just erased the third. But, and then minus e to the 0, which is just 1. Yep. That's, and then we integrate that. Oh, yeah, that's what I forgot. So, don't be dumb. Remember that you're multiplying the x times everything in the equation, because e to the 0 is still multiplied by x. Don't do what I did. But next we take the integral from 0 to 1, and that is going to be equal to, taking in respect to x, you get x. Oh yeah, you have to do u sub for this one. Okay. So it's the integral from 0 to 1 x e to the x squared minus the integral of 0 to 1 of x, and this is all dx. So it's all dx. Let's just work this last bit. U is equal to x squared. Du is equal to 2x dx. So from u we do the u sub rule. So it's 1 over 1. And that becomes the integral from e to the u du times 1/2 minus x squared over 2, 1, 0. I just integrated the right side because, I mean, why not? And then this is going to be just e to the u, right? Yeah. And you don't change the bounds because it's just 1. So it's 1/2 times e to the 1 minus e to the 0 minus 1/2. Okay, and what we do after that is how did she get 2 from that? Because of that, yeah. Wait, that's really interesting. She put e to the 0 as -2, which, I mean, it becomes 2. Wait, why did she do that? Why? I'm just gonna put e to the 1 over 2, and then minus 1/2 minus 1/2 equals just -1. And that's your answer. Alright guys, bye. Alright guys, so this is number 4 of test 2. And this is converting to polar of a double integral. So we have the integral from 0 to 2, 0 to the square root of 4 minus x squared. And from polar, we know x squared plus y squared is equal to r squared. And we know y is equal to r sine theta, x is equal to r cosine theta. So from the trig identity, cosine squared theta plus sine squared theta equals 1, we get that cosine, so r squared cosine squared plus r squared sine squared is equal to just r squared because it's just equal to 1. Now, I don't understand why it's not like 2r squared, but I think it's because this and this is like cosine and sine add up to 1 because they're intervals. They're like, the graphs are like, and then the cosine graph is like, you know, so after adding them both up, you get like 1 or something. I don't really know, but from doing that, because y is equal to 0, y is equal to square root of 4 minus x squared, we can go over here, which is where I wrote this, and we get y squared is equal to 4 minus x squared, and then by putting x squared over there, x squared plus y squared we already know is equal to r squared, so it's r squared is equal to 4, so it's r is equal to 2. So the 0 is still there, and just a little double, more polar for you, dy dx is equal to r dr d theta. So it becomes, so it's r squared times r dr d theta. And then, so this one is still going to be 0. The y is equal to 0, r is equal to 0. But this one is going to be 2. And so the next one is x is equal to 0, so it's still going to be 0. And then And then, that's really weird because if x is equal to 0, you make x is equal to 0. Anyway. You get, so the reason why this next one is pi over 2 is because when you have a graph of a circle, this over here is negative for sine and positive for cosine, right? Yeah. No, it's negative for cosine, positive for sine. Since we're only going to 2, and this is in the x direction, I'm pretty certain we only stay in the positive of the x. So we stay in here. So we could be going from negative pi over 2 to pi over 2. But in this case, since we're going from 0, we're just going to 0. Oh, I understand it. Ah, that's great. But, okay, and this is our integral. So now all I gotta do is work it. And what we get is r to the 4th over 4. Actually, this is a good teaching lesson because I almost made a mistake. What is this able to do? It's able to be separated because, you know, d theta dr. So what we get is 0 to pi over 2 times 1 d theta, and then this is times 0 to 2 r to the 3rd dr. And that equals pi over 2, because it's just theta minus theta 0. Well, theta minus theta and pi over 2 minus 0, so pi over 2 times r to the 4th, which is 16 minus 0, so 16 over 4. So it ends up being 8 over 16, so it's just going to end up being 2 pi. And on my test, I got this wrong because I forgot that it's from 0 to, I didn't realize how it was from 0 to 2 pi over 2. I thought it was from 0 to pi, so I got 4 pi. But in reality, I figured out why I was wrong. It's 0 to pi over 2 because it's in the positive cosine. And that's something I'm really proud of. But anyway, on to the next equation. Yeah. Okay guys, so this is problem 5, and from this triple integral, we have to ascertain that since it's x minus 2y plus z, if you can read that, it's the integral from -1 to 1, 0 to 1, 0 to 2, x minus 2y plus z, dy dx dz. Because it's all added up, plus subtracted, we can't separate it. So what we have to do is we just have to take the integral 3 times. So first is in respect to y. So what I do, okay. xy minus y squared plus z y. And that is from 2 and 0. So what we get from that is 2x minus 4 plus 2z. And then we take the integral from 0 to 1, and this is in respect to x. So the next one is x squared minus 4x plus 2zx. And 1 is 0, and that's going to be the integral from -1 to 1, and so it's 1 minus 4, so that's -3, and then 2z minus 3 dz, and that's it. Now it's the last bit, so z squared minus 3z from 1 to -1. So from this first equation, we get 1 minus 3, negative 2. This is the part I went wrong on my test. Instead of negative 2, I put positive 2. But that is minus negative 1, so 1 plus 4, so that's 1 plus 3, so that's 4, and that is going to give us our answer of negative 6. And the only thing I got wrong, she gave me full points for this, which love her for that, but I did 2 minus 4, so I got negative 2, which is kind of funny. But that's triple integral, guys. Pretty easy one, for sure. Pretty easy one. Alright, next question. Okay, guys, so this is problem 6. And this is find the x-coordinate of the center of mass of the region in the first quadrant bounded above by the line y equals x and below by the parabola y equals x squared. If the mass equals 1/6, oh, I did something wrong. If the mass equals 1/6 and density is equal to 1, figure it out. Okay, so on my test, the one thing I got wrong, and she gave me full credit for it anyway, which I really don't understand at this point, is I put it from 0 to x squared, not x to x squared, which is what it should be. I'm really confused on how I got full credit for this question, because I shouldn't have. It should be from 0, I put 0 to x squared instead of x to x squared. So I was wrong. But we're going to do it right this time. Okay, and this is a pretty easy double integral. All we got to do is take the integral in respect of y. So what she did is 1 times y x squared x and pretty much x squared minus x. So what you get is x to the third minus x squared, and 1, 0 dx, and that's going to be x to the 4th over 4 minus x to the 3rd over 3, and no plus c, times 6. Gotta make sure to remember the 6, and that's just 1/4 minus 1/3. Third times 6, right? Am I doing all this right? Oh, I did it wrong again. Well, that's great. So don't be a dummy. The lower bounds is x squared, right? So I wrote it on my paper wrong again. Since the lower bound is x squared, the lower bound right here is going to be x squared. So instead of x to the x squared, it's x squared to the x. So I just kind of reversed it up a little. But what we get is x to the square minus x to the third. So pretty much the same equation, except I flipped it. And what we get here is x to the third over 3 minus x to the 4th over 4. And then you get 1/3 minus 1/4. I was thinking, I was like, why am I wrong? That's why I'm wrong. Okay, next is just the little bit of simplification 4 minus 30 over 12 times 6 equals 1/2, yeah. I gotta make sure I know what I'm doing. Especially for a video I'm trying to help other people. But yeah, that's finding the x-coordinate of center mass. It's kind of easy, and you know, you can do, there's another bit of math I might do later, but I'm about to go to the gym, so this is part 1. I hope y'all enjoyed. Part 2 will be out soon. Okay guys, I just got back from the gym. Let's get this third problem done with. Now she marked this wrong, but it was actually completely right, which is really weird. Okay, so get my marker out. Okay, is Z first? Yeah, Z is first, so Z stays the same. 0, no it doesn't. Oh. So x squared plus y squared, r squared, z is equal to r cosine theta, because z is equal to x, because z is equal to 0, 0 is equal to x. So the next one is y is equal to 0, y is equal to square root of, so y squared is equal to 1 minus x squared, which means r is equal to 1, because, yes. Okay, and then the last one is pi. Oh, I see what I did wrong. For dr, I put 0 to pi over 2. Oh, I just integrated it with, like, instead of dz dr d theta, I did dz d theta dr, and you're supposed to do dz dr d theta. Yeah, so r is equal to 1, and oh, it's at what? Okay, well, she has it wrong. Surprisingly, she surprisingly has it wrong. Like, actually, on the review, she has it wrong, because it's the integral from -1 to 1, but she has it from the integral from 0 to 1. So I'm gonna work out. If I work out -1, it's going to go from -pi over 2 to pi over 2. But if I work it out from just 0 to 1, it's going to be 0 to pi over 2. And that makes me really want to just... Or is it going to be 0 to pi? Wait. Okay, I'm sorry I'm taking a bit. I'm trying to decide my next course of action because, I mean, it's wrong. And I'm trying to figure out cosine. So if it's at the bottom, I explained this earlier. If it's at the bottom is sine of -1, but it's still positive. But we're not doing sine, we're only doing, oh, I get it. So if it is sine, how are you supposed to do quadrant 4? When you have a circle, cosine of 0 to pi over 2 is 1. It's 1 to 0. It's a -1. But if it's sine, it's going to be... That's weird. I guess because it's area, we don't really have to care about. That's my scooter. Don't say that. I was thinking of painting my scooter hot pink because somebody called me something the other day. I was like, well, alright, might as well. So the limit is. So I did it wrong. I did it incorrectly on my test, and I should have had it wrong. But she has it wrong on this. Let me check the other review. See if the other review has -1. Because it's the last problem. Okay, yeah, the other review has -1 to 1. And the same exact numbers. Okay, and I was thinking, oh, it's gonna be 0 to pi, 0 to 1, and then 0 to r cosine theta, and so you get r squared, so it's gonna be r to the third, dz dr d theta. Okay, and I'm pretty sure that's what we're evaluating. Yep, I am correct. That's great. Okay, so if you integrate, you get z, and then it's going to be r to the fourth cosine theta, dr d theta, integral 0 to 1, 0 to pi. Okay. And then you just, so this is a case where you can do separable, which is really nice. So it's 0 to pi of 0 to pi of cosine d theta, because that's the outer bounds, and then times the 0 to 1 of r to the fourth dr. So it becomes, okay, cosine of pi is -1 minus 1, because cosine of 0 is 1. So it's going to be -2 times 1 over 5 minus 0. And so that's just -2 over 5. And let me just make sure that is correct. Pretty sure it is. Oh, no. I see what I did wrong. I didn't integrate cosine. I didn't integrate cosine correctly. Sine of pi and minus sine of 0. And both of those are 0. So it's not that. It's just, well, sine of pi is just 0, and negative sine of pi 0 is just 0. So it's 0. And that's it for test 2. Alright, guys. Hope you enjoyed this study. Oh, my phone. Well, you know, it might be a little wonky for this last video. But guys, I hope you enjoyed, and, you know, do well on your test too if you're taking that.